So this is the first lesson on Handheld and Dynamic-BFF. We're gonna focus primarily and initially on the Dynamic-BFF, that it's the server side of the application, and then my colleague Roberto will focus on the handheld extension of the Dynamic-BFF. Now, I'm going to explain you a little better about the new Dynamic-BFF approach. So this is the current architecture of the Smile system. Well, of the interaction between the current web UI and the legacy Android mobile application with the BFF. And it's the classical approach of the web APIs and microservices, with a little microservices composition on the server side, where we can see the HTTPS connection from the BFF to the BFF itself. And as we already know, the BFF currently uses a few SQL Server databases and interacts with the LGV manager via WCF. There is a little Rabbit interaction with the backend, and there are a few non-Smile 80 systems integrated with the BFF on a few projects. Now, the new Dynamic-BFF approach does not remove anything from the current architecture, but there is a new Dynamic-BFF backend component that interacts with the BFF, with the current BFF. That it's not going to be removed or replaced by the Dynamic-BFF, but it's a new component. So it on the left side, as you can see, the Dynamic-BFF is perfectly equal to the current BFF. That means that it uses the same databases and interacts with the LGV manager via WCF. And there is the possibility to integrate non-Smile 80 libraries. Now, on the current version of the system adopts the Dynamic-BFF only for the handheld mobile application. And it is currently under development an extension to the Dynamic-BFF in order to make him interact with the web UI, but it's not something that we're going to talk about today or even the next Monday. So currently, the Android mobile application that we've just developed interacts almost, well, exclusively with the Dynamic-BFF and does not interact with the legacy, with the current BFF, the not Dynamic-BFF. But in case, if needed, the possibility is there, and we'll see how it works. So what is this Dynamic-BFF? Well, the Dynamic-BFF is a couple of things together. It's the domain-specific programming language that we're going to talk about in the next slides. It is a compiler for that language and an execution environment. As a recap, at least for a few of you, what is a domain-specific language and what is this domain? A domain-specific language is a programming language that focuses on a specific domain. in contrast with the general purpose language as C# or Java or whatever. This language does not allow you to build up any kind of custom application, but it is restricted to its domain. And its domain is, as the name suggests, it's that of the BFF. That is the backend for front ends in general. Currently, we have two front ends, the mobile application and the web UI. What does it mean? This means that you can only create web controller actions, because this is the domain of the backend for front end. And your code will always run inside an ASP.NET Core environment. So this will be totally transparent from the developer point of view, but it is important to remember it's because there could be the need of extending the system using native extensions. So it is important to know that these extensions will be coded in C# and it must be compatible with an ASP.NET Core environment. So what are the primary advantages of the dynamic BFF approach? Well, it will be way easier to upgrade the Smile system, because you do not have to modify it. So our side of the upgrade will only be to replace the current version with the next. And regarding the specific code of the projects, hopefully it will be 100% coded using dynamic BFF language. So there will be the merge of the code, but it will be really straightforward because it is very compact and easy to read, I hope. Then the project code is significantly reduced, because that domain-specific language is restricted to the domain, and so the keywords and the language constructs will be dedicated to their job. So it will be very, very compact and easier to maintain. The project code is safer, because any kind of code injection or bug or unsafe third-party library will be in a jail. So what the code really will be able to do is governed by the runtime environment. So the project code is reusable across different Smile versions, at least with a few limits that we're going to discuss eventually later on. But if you write some simple web APIs or user interfaces, it is very, very easy to bring it from one plant to another. And last but not least, changes do not require the developer to rebuild Smile components. So you don't need to dig into the Smile code and to have working compilation and deployment environment on your PCs or other build environments. So, very simple diagram of how it works. There are a few ingredients that must be fed to the dynamic BFF compiler. that are the DBFF source code and the Dynamic-BFF runtime in green, that are the new ingredients of this recipe. And then there are the classic ingredients like the database, the non-Smile libraries, and the Smile services and libraries, the LGV manager, for example, or at least their interfaces. So the Dynamic-BFF compiler reads up the Dynamic-BFF source codes and produces C# source code. It is transparent to the developer. The source code is never saved on a disk for security reasons, and it will be generated in memory. It is compiled by the Roslyn compiler in memory, and a .NET assembly is then generated. This assembly will be linked to the runtime library for the basic functions and the constructs of the language, to the Smile and non-Smile services and libraries in order to adapt the data to store procedures, WCF calls, data and the data types. Then this linked assembly is loaded and run as a .NET Core, an ASP.NET Core environment, where everything will run in a single virtual machine. So from the ingredients, we will now focus on these two ingredients, the source code and the runtime, that is the basic library of the language that provides a few utility functions. Okay, let's go see some code. As a programming language, we start from the Hello World application. Now, we have a few constructs here to look at. First of all, we declare a web API, that it's a controller. It will be translated into an ASP.NET controller, so it's the root of a few endpoints with different HTTP verbs and stuff like that. And to this web API, we feed a path. It is perfectly equal to a .NET controller with less boilerplate code. So it should be quite straightforward. Then inside this controller, we declare an action that responds to an HTTP GET request with path hello world. And on success, and having no code, we all hope that will be a successful call. On success, it will return a string, hello world. So everything these actions get as parameters and return will be JSON and must be JSON encoded. So we expect to receive a valid JSON in response. So let's call this hello world, and we receive an hello world JSON. And yes, this is a valid JSON string, even if it has no curly braces and stuff like that. A quoted string is a valid JSON string. So this is JSON encoded. As you can see here, it's valid JSON, and we receive a 200 HTTP OK response. So in these 8 lines with 2 blank lines, so 6 total lines of code, we have everything that we need to declare and run a server-side action, get action. So I hope it is clear for any one of you. I don't know if you usually make questions during the presentation or if all the questions will be at the end. Anyway, for me, there's no problem. So if you want to interrupt me, just do it. So now we're gonna add a simple assignment line with this, I think, very readable syntax. And as we can see, we are assigning a variable that it's already inside a namespace. What does it mean? In this language, you cannot explicitly declare variables, and it is an untyped language for simplicity. Underneath, there are obviously data types, as everything is translated into C#. So, but these data types are totally transparent from the developer point of view. So the only way to say that this variable is a string is to see what is assigned to it. So all your variables declared locally in an action will be automatically generated as soon as you assign something to them, and will reside into the local namespace. This namespace is created on the very first line of the action, and it is automatically garbage collected at the end. So it's a short-lived namespace, and all the variables declared inside here will be lost at the end of the action. It is primarily used to store temporary variables before us returning them or writing them to the database. So we set this new my variable to the string hello world, and we return it as it is. And as we can see, we receive exactly the same answer. So this is just an assignment of it. Then we add another line, a second assignment to a number. As you can see, there are no explicit types here, so we know that this is a string and this is a number, and we return the whole local object. So I expect to find into this object these two fields. And as you can see, okay, now we have something that resembles a way more a JSON object. It is an object with these two fields perfectly encoded as a JSON, and he understands that this is a string and this is a number, and correctly encodes it in JSON, even if we didn't say that this must be a number. So let's start with some simple expression. Here we assign a third result variable to the sum of these two numbers. So we just have added an expression to our code, and as previously done, we return the whole local object. And we expect him to do this simple calculation, 110. Hopefully it is correct. It is. So as you can see, expressions behave as expected. Now, data types. Okay, now we're gonna complicate it a little more, adding a few other implicit data types. We've already seen integral numbers, strings, then we have Boolean values as constant values true and false, or as a result of an expression, as we will see later on. Null is not exactly a data type. It is an untyped constant. So any kind of variable or object can be valued to null. And there are dedicated functions for handling null values, as we will see later on. JSON objects are native data types in this language. Here I have used double quotes for the keys, but it's not mandatory as in the JavaScript language. So you can add expressions as values, and you can add integrals and nulls. And as in JavaScript, you can have statically declared arrays where you can put constants and previously valued variables, and you can access, obviously, nested objects. So this nested object refers to this one. Null is obviously handled inside objects and arrays may contain objects and arrays itself. So let's return this quite complicated and messed up object. And here we are. We have these objects with all of its values and arrays and nulls and booleans and numbers and everything we've declared here. So I'll let you look at the code a few more instants before passing to the next example. Think that if you know a little JavaScript, this is absolutely obvious. So a little more showcase of operators. So in the very first part of this script, we can see we have a few compact declarations of scalar values, arrays, and objects. And let's proceed to do some calculations. I will open up this example just now in order to have its response available here, so we can look at the operations one by one. First one, we're gonna add two integral numbers, and we have the 1 and the 10 in plus num res. Plus num res is 110. So string plus a string makes a string concatenation. So here we have our hello world that concatenates this hello to this word. Quite straightforward. We can concatenate arrays because we can do it. And so we can see we have two arrays, 1, 2, 3, and A, B, C, that are concatenated just here in the response. And we can remove elements from an array using the minus operator. So we have the 1, 2, 3 array as an input, and we have the 1, 2, and that's it array as a result. The element must be perfectly equal, and he will find out where it is without calling method, but just using operators. That's fun. So the multiplication works as expected. So it does the multiplication on an integral number, and less obviously, if you multiply an object, you can replicate that object on an array. So multiplying by 2 an object produces an array cloning the object num 2 times. So as we can see, this obj is now an array with a cloned copy, that it's effectively cloned. So if we modify this second one, the first one remains intact. Then we can divide a number, and it will be an integral as a result. So 37 divided by 2 is 18, because the current implementation does not handle calculation on floating point numbers, because, well, primarily because it wasn't needed for the current implementation, but it is on our backlog, and sooner or later I will do it. I hope so. Then you can divide an object by a string that is used as a key, and divide an object by a string means to remove that key from the dictionary. So the ABC object is just an AC object as a result. So, few other expressions. Now, there are obviously the comparison operator, where this is quite very, very straightforward. So we can do greater than, hold on a second. If we need it, we have the result, but I think we can hurry up a little here because it's quite straightforward. So we have the greater than or equal, the equals operator. The equals works on nulls. You can do different from null, and everything here works as expected. Here we have something more interesting, that it's the triple equal. If you know JavaScript, JavaScript has a triple equal, even if it behaves a little different, because triple equal in JavaScript, it's a mess from my point of view. Here, the double equal operator on the object and compares the pointers to that object. So even if we have a perfectly equal object that it's a clone, so it occupies a different cell in memory, it is different from the double equals point of view. Instead, from the triple equals point of view, two objects are equal if they contain the very same keys and values. And this equality is deeply evaluated. So if an object contains an object, on that nested object, the triple equals is applied in order to say that two objects are triply equal between them. And the very same reasoning has been done on arrays. So two arrays are double equal if they are the very same array in memory. Instead, they are triple equal if they contain the same values. So very quickly, as you can see, 1.7 and 1.8 are false and true as expected, because obj1 is a perfectly equal clone of obj2.sphere. And here we have x and y valued 1 and 2. Very same thing are the arrays. And these two arrays, 1, 2, 3, I think, and 1, 2, 3 are in different places in memory. So the 1, 9 is false, but they contain the very same values. So 1, 0 is true. Now, logical operators and, or, and not behave as expected. So I think we can skip to look at them one by one. And we just can say that we have the indexing operator that works, that even this one works as in JavaScript. So arrays can be indexed by integral numbers, while objects can be indexed by strings. And then there is the collage operator that returns the first not null value. evaluating left to right. So first, the left side of the tilde operator is evaluated. If it is null, the second one is returned. If it is null, even this one, the result is null. So this works as the double question mark in C# or the call-hash function in SQL. Now, we have a few built-in functions. Don't be scared by the number of lines of this example. We can go quite fast through them. So this first block is just a declaration of a few static values. We can count the values. The count of an array is the number of elements in that array, while the count of a string is the number of strings. So it is 1, because the length of the string is evaluated using the length function. So the count returns the number of elements in a collection. If it is an array, the number of elements in an array. If we pass just a simple variable, a string or a number or a boolean, it returns 1, because that is just one variable. The count function takes as an optional second parameter a lambda function, where we can filter the elements of the collection. So if in this collection we say that any object, the subject of a lambda expression is by default obj, it's a conventional keyword. So if we filter this array of integral numbers, saying just return all of them, all of the numbers that are greater than 5, we receive as res32. It is somewhere. Oh, not here. This is number 8. Yes. Well, it is somewhere over here. I just will let you find out where it is. Anyway, it filters the elements in the array. So we have already introduced the length function that was as expected. str coalesces to a string anything we pass on, eventually encoding to a JSON string lists and objects. I use the words list and arrays to refer to the very same data structure, because what it is used underneath is nothing that you will ever see. So lists and arrays are the very same thing in this language. There are a few other utility functions that I will not stop on here. These are all documented inside our private documentation. So you will find many details, I hope, about them. The only one where we can spend a few words is the each, that it's the for each loop that works as a map in JavaScript, more or less. So we have a collection and a function on that collection that transform every single element. This is widely used inside our scripts. Then we must absolutely focus on the map function, that it's very, very, very important, an important construct of this language. And it allows you to transform objects into other objects in a very lightweight way. It's very fast, and it allows you to remap objects without allocating and wasting tons of memory. So it is very widely used inside our base scripts. So what does it do? It remaps. So we have this object, this sample object with the X, Y, and the T keys. Sorry, this list of objects. So this is something that resembles the result of a select function on a view or on a table. So we set this ARES1 variable to the mapping of these objects. And how we remap these objects? Well, we create a list of objects with these 4 keys. The A key contains just the copy of the X field. Just remember that obj is the default name of a lambda function in Dynamic-BFF. So this obj is an obj that it's passed to this transformation while the map function loops inside the AOBJ list. So A contains X, Y contains Y, because contains X plus Y, so it does an arithmetic sum, and the text contains this concatenation of the constant text and the value of T. So a res1 is here on the right. So A contains 159 and naught, and here are the x's, y, and the sum of 9 plus 11 equals 20, and the 159 naught strings are concatenated to the text constant. I think it's quite straightforward. So then we have an ARES2 that it's the very same transformation, but with the OBJ removed, because it is not mandatory to use the OBJ dot. If you write a reference like X or Y, it defaults to the obj dot X, Y, and T. So this obj dot, it's not mandatory, but if you find it useful because it makes it more readable, you can use it or not on your choice. Then we have another few examples of the map construct. We have a special keyword that it's the star. The star means take the object on the right side and just replicate a single line with every field of the obj, in this case, object. So what does it mean? It means that the ARES1 object will contain the sum key that we can find it here, and all of the fields of the obj object. What does it mean? It means that this construct allows you to enrich an object with a new field with the result of an expression that it's computed on every single item in the input list. And it's something quite useful. So this thing here is list concatenation. As we have seen in the previous example, you can concatenate two arrays or two lists using the plus operator. So as map is a function construct of the language, it can be used inside expressions. So the map and construct can be sum to another map, for example, and the result will be the concatenation of all the x values and all of the y values into a single list of objects that contains only the value key. So here we are. The ARES2 is a list of objects, and every object contains the value key, value and value, with all of the x values, 1, 5, 9, and 0, and the y with all of these integral numbers concatenated. Then we have the very same input here. So this is perfectly equal to this. So the input of the each function here is exactly this list. So what are we saying here? Take these input list, and for each of these objects, extract the value field. What does it mean? It means on these objects, for example, just return 1. So here we have the ARES3. It's an array of integral numbers with all of the original x values and then the y values. Then, as a corollary, map is an expression construct again. So it can be used where an expression can be used. So for example, as the value of another map. So we are mapping a map here. This map is mapping this map. How? On the input list, we are saying that we extract a new key that is sum. Let's see. Let's look at it here. So create a new key that is called sum, that then create a new object that is the mapping of a single object this time. So if map receives a single object as a parameter, it will map just a single object and returns a single object. So map the obj of this iteration. So this object, then this object, and so on, and map that object to another object, extracting the two x and y keys and assigning them new names, first value and second value. And this is the result. A sum field equal to the sum of x and y with a new key here that it's named values, that it's equal to an object with the two new fields, first value and second value, that are x and y, just renamed. Quite powerful. Now, we've finished with the basic language construct, and we approach now a few new things like query strings and body parameters. Now, there is no explicit distinction between query string and the body of a request. As previously stated, this language allows you to handle only JSON object as inputs and outputs. So this obviously applies to the body of the post requests and not to the query string. And the body of the request as a JSON object, it contains a few keys and values that are typed at least with the type data types of JSON, so strings, numbers, booleans, and the null meta value, and objects and arrays. So we can underneath give a data type to the body of a post request using the JSON hints. This does not apply to the query string. So query string parameters can only be strings, as the name suggests. So if we pass an integral number as a parameter by query string, we will have a string as a value in our subsystem. And so I suggest you to avoid the query string as much as possible because of these. Now, how do we read parameters, whether they are query string or body post parameters? The first example here, we have a get named myGet that reads a first query string parameter, assigns it to a param1 local variable, and returns the whole local object. As you can see here, the result is, as expected, the whole local object with this single variable that we've declared here equal to the request.first. So if we assign it a new string, it will return the local parameter with a new string that it's the query string, you see, query params, query string that we are sending to the server. Then we have a more interesting post request. Let's look at it here. We have the post. This post request takes a first hello world parameter as a query string parameter, and at the same time it sends to the server a JSON object as a body of the request with two keys named second and third, because the first is the query string one, and the first one is a string. It's another string, and the third is instead a JSON quite complex object. Here we assigned these three first, second, and third parameter to param1, 2, and 3, and return the whole local object. And as you can see, we have the param1 that is a string on its query string, param2 as a string, and param3 as a complex object. If we change this here, so if we change to 1, 2, 3, the query string parameter, and we change to 3 to 1, the second parameter, as you can see, the query string is still a string, while param2, having received it from the typed JSON object, it is correctly converted to a number. So yes, this is it. Then next example is an if. Well, I think I will not spend many words on the if statement. It works as expected. The expression parameter of the if is evaluated to a boolean. So if this value that it's 37 is greater than a request parameter that it's sent via this JSON object, my param that it's 12, and 37 is greater than 12, so I expect to receive local.res equal to hello. Here local.res is returned, so I think we will receive a funny hello from our server. We obviously can change this to 121 and receive a world, given that the system has chosen the else branch to evaluate. So in this example, instead, we have a probably more interesting example of another expression statement, that it's the switch. Switch evaluates this expression and then chooses a destination to go to, and there is no explicit break because there is no possibility to fall back from one case label to another, because it generally causes difficult to spot bugs. And in order to keep the syntax more very easy to read quickly, I've chosen to not to allow to fall back from one case label to another. So there is no break needed before the end of the case statement. So here, an integral parameter 10 is evaluated, and I hope that this switch will choose the case 10 here and return us the string 10. Here we have another example where we use as a switch argument not a scalar value, but an object, an array in this case. So we pass the 0, 1 array, and the system is able to map every single cell in this array to a case label. So the system will hopefully choose this case label to evaluate and return us the string 0, 1. And here we are with 10 and 0, 1. I've said nothing about the else, but the else is chosen if none of the labels match, obviously, and it is optional. So if the switch expression is not matched by any label and there is no else statement, then the switch operation is effectively a no-op. So next, let's start to play with the database. No, we don't say that. Now, queries to the database are issued via the query statement. In order to issue a statement, an SQL statement, we need a data source. So how we say to the system that we need a particular data source, we say that our entire web API, so the entire collection of actions, here we have a very poor collection with just one request, but we can have collections of many requests, as we have seen, I think, before, or not, maybe. So we declare a default data source. This means that in our query statement, we do not need to say on which database you have to issue the query, because the default for this action is this one. If we need to use a different data source for our query, we just can add on data source, a data source statement, smile API LGB manager, for example. But usually we work in one action, we work with just one database, but there are a few exceptions around. So we declare the default data source that it will be shared between all of the requests, all of the actions inside this controller. And we say select stuff from inventory.lgv code. And as you can see, we do not tell the system where to put the results of this query. Why? Because by default, the result of a query statement is inside an object with a system name that it's result set. Result set is a meta variable that contains the list of objects that is the result of the last issued query. Inside an action, we can obviously have more than one query, so we have to save that result set inside a local variable, for example, in order to use it later on if we have to issue more queries in the middle. So if we ask the system to issue that query and on success to return the old data set, as you can see, we have an array, a JSON array containing many and many objects that are the result of that query. It is important to remark that all of an action runs inside a single transaction, that it's automatically handled, rolled back in case of unhandled errors, and so on. There are a few statements that allow you to explicitly commit or roll back a transaction. In that case, if you say commit after a DML query, he will commit the current transaction and transparently create a new one. So the next query will run inside a new managed transaction. Then queries can have parameters. Let's say that we want to filter the previous query using a simple where alongside is greater than parameter size. Parameters are explicited using the SQL Server standard @ sign. So we say that this size parameter is equal to request.size. Hold on a second, please. Okay. Size is 777. So as you can see, this is a get. So this is a query string parameter. And as we have previously seen, this is interpreted as a string, but you do not have to convert the data type because during the compilation phase, all of the SQL is reverse engineered and the data type of all of the parameters is inferred from the query metadata. And this parameter assignment will convert request.size from its current data type, in this case, a query string, so a string, to the correct data type for alongside that it's an integral number of some species. So this is totally transparent to the developer. Then we have an assignment of local.res to an object, and this object contains the query string parameters that we have passed here as request.size into the field, the object field size limit. We have the maximum value of size that it's obtained directly from the results of this query here in the result set. And I say, for each of these results, extract the value of long side. Then, of this array of integers, extract the greater, the greatest, that it's the max function, and put this value into the max size key. Then we have this matching field that it's a remap of the result set returned by this query, where we rename the name field into name, but with a lowercase n, and then we construct a string that it's the concatenation of a string, an empty string, in order to cast this whole string to a string. Otherwise, he will try to add alongside to a string, and this follows other rules. So we have to ask the system to produce a string from this sum and not an arithmetic sum. So we concatenate the double quotes to long side that it's converted to a string thanks to this empty string, then the blank x blank string, and then the short side, producing this result. Let's not hide this first parameter. So we have an object as a result with size limit equal to 777 as a string, in order to show you again that is a string. We have the maximum values of this size that it's extracted from the result set. This means that it's extracted from the database, so it is a number alongside. And we have the maximum value. Then the list of matching with the lowercase n name and the size 1200 by 800 unit of measure. So yes, this works as expected. Then the last thing we have to see, oh yeah, it's the lowercase result. As we have seen here and even here, this result set, uppercase result set constant, contains the list of results of a query. But if our query by design returns a single row, it is quite useless to say anytime return me the first row of this single row. So we have simplified a little this problem using another named variable that it's the result lowercase result object, that it's the single result of a query. So we have this query here that it's where on an ID, so it will hopefully return just a single row. We pass on this ID as a parameter. As you can see, it is case insensitive, as SQL Server is, unfortunately. And so we have no solution for this because SQL Server returns metadata, its metadata using just lowercase letters, not always, but sometimes. So yes. So result is null if no results are if no rows are returned by the query, and null is false by construction. So if on result, you will get a false if there are no results, and a true if there is a row returned by that query. So this means that if we and yes, if we have a result, we return the full result, that it's the returned object, and again that wonderful string that contains the long side by the short side of this LGV code. Instead, if we have no results, the for result is explicitly valued to null, while the size is constant 0 by 0. Why not? So ID3 exists, and this is the full result of this query. If we ask 399, we obtain no results, and trust me, the ID 399 does not exist, and the full result is null as requested, and the size is 0 by 0. So this is quite a straightforward syntax, I think. So many words have been spent for the select. The insert or update are more easy to be discussed. If we have an insert query, you just write down the SQL, and instead of the query construct, you use the SQL. That it's a very generic way of meaning just do what you want inside here. If you have parameters of some kind, I will handle them for you. So we are inserting all of these parameters. We are using here these parameters. We use here the call-hash operators. So if else side is not passed, is implicitly a null, and we do not want to insert nulls, so we say request.elside, but if request.elside is not passed, just insert 0 instead of null. Then we have, as a result of the insert statement or whatever SQL statement, we have, as a result, another meta variable that it's called a row count, that contains the number of rows that have been modified by that SQL statement. That is a number greater than or equal to 0. And this number is just set, is just written into the inserted rows local variable. Then a query statement is issued requesting the number of rows of LGV code, and this number is named total LGV codes. And then we create this status string with this string concatenation. Quite straightforward. We will not spend many words on this. Let's try and insert ID 101. And yes, it worked. It says inserted rows 1 as expected, and rows inserted 1, rows 9, and rows now 19. If we try and insert 102 and we call him test2, rows now 20, so it's working. Now, store procedures. Store procedures do not require you to write SQL. I will write it for you. By using the exec statement, you ask the system to create and send to SQL Server the SQL needed to execute the warehouse.usp add block store procedure. The store procedure requires all of these parameters. These parameters are, maybe we can look at that procedure later, maybe. If you want to look at the source code of, I see a raised hand. Chiara.
Just a curiosity, but in this way, you can execute actions with a get statement?
Yes, absolutely. You can do whatever you want in a get, in a post, or in a put, or a delete. Everything is allowed here, and technically there are no
There are no restriction on the.
nope.
Okay.
There are no restrictions. The only thing you have to care about is that if you use a get, you have strings for all of these values. So now we have a very simple store procedure execution that just takes the query string as it is and assign it to the parameters. So the subsystem looks at the source code of the store procedure. He knows that ID container is a numeric value, so he generates the code that it's needed to convert the string received from the query string to an integral value. But there is no problem, no technical problem on this. I suggest you to use post actions to do actions and get requests.
Okay, so there are some
to,
guidelines or something.
yes, there
Best
are
practice.
guidelines
Okay.
and best practices. Absolutely. Sorry for that. You are absolutely correct. And my example does not follow the general guidelines that are not EAT guidelines, but are worldwide accepted guidelines. So my fault, yes. But given that I did not spot this little mistake just because there are no technical restrictions on this, but just best practice, and you have and you are again absolutely correct, and thank you. So if there are no other questions, I proceed. Oh, there is one other question, two other questions. Oh, it's question time.
Ciao,
Oh.
Mattia.
Ciao.
Quick question. Talking about guidelines, I see that there is a lot of manipulation of SQL code, of SQL data in this language. And I'm wondering if it's easier for us to directly do our data return on SQL and then just print out the values here. Like, are we allowed to create functions, views in SQL and then return those?
Yes.
Instead of okay.
Well, I must now give you my point of view. There are no general or group or project guidelines on this. My suggestion is if your SQL is quite straightforward and does not mess up the code, you can write the SQL code here inside the script. If you have a complex logic that, for example, a view with 5 to 10 tables involved, or just create a view and use it from here. Again, if you have many inserts, deletes, updates that require you to validate input data on other tables, in order to avoid to mess up the code and in order to speed up the execution of the statements themselves, I suggest you to write a store procedure. Again, there is no guideline here. It is up to you to look up to look at the code and see if it is easier to read a select from a view or a select from a very, very complex SQL statement. But again, this is my personal suggestion. But when we will look at real code that my colleague will present later on, you will see that this approach is more or less replicated in the base scripts that we provide that we will provide to you. Hope this answers your question.
Yeah, it's just to keep everything in one place, you know, not have a little bit here, a little bit on the SQL.
Yeah, absolutely.
Okay. Thanks.
You're welcome. Up to you. Juan?
Mattia? Okay.
Yes.
Hi, Mattia. Sorry, I didn't want to interrupt you. It was just
You're just the third.
Just to, yeah. No, I'm just saying, after you're done with the 21st examples, if you can take a look at the chat, I wrote some question on that. So just to tell you that there are questions on the chat as well.
Oh,
so
okay.
Later on, don't worry.
Okay.
After you're done with the examples.
Sorry for that. I am looking at the wrong screen at the moment. Okay, but I see that my colleague is already intervening.
Yes, but since I'm not even sure that everyone is reading that, so maybe later after you're done with your examples, we can go through the questions so that everyone is aware.
Yeah, next example are quick. Don't worry.
Thank you.
Oh, you're welcome. So here we are calling a store procedure that some of you probably already know how it works and what is it about. We set the parameters of the store procedure, taking the values from the query string, and on success, we returned an object with the output variables of the store procedure. So now it is time probably to quickly look at the code of the store procedure to make it absolutely clear. Okay, I think that nobody can see anything at the moment. Okay, here we are. I hope. Yes, okay. Let's click on this one. So, for example, we have ID container block as a big number declared as an out variable. How we can obtain this variable value from inside the script using the output namespace. The output namespace is automatically valued. It's an object that contains a key for any of the output variables of the store procedure. It is an empty object if the store procedure has no out variables, and it is wiped every time you call a store procedure. So as for the result set meta variable, you have to store these values inside the result object if you need to recover them during the script and after having called other store procedures. Now here we return it's the very same example with the remove block this time that needs just one single parameter, and we return the all output object. So we can quickly go to this. Okay, we have issued the first add block with these parameters and is returning this block ID and result code as 0 because this value is null. And we remove the block with another one. I don't know if the IDs are correct, but we have a result. Yes. Okay, as you can see, the output contains result code, result text, and return value. Obviously, in this case, result text is not resolved with the parameters. You can do it you can do it with the constructs that you probably already have seen. Now, until now, everything worked well. I have been lucky, but sometimes things go wrong. So we have dedicated statements to handle errors and failures. First one is very easy. It's the fail construct that is used to fail. If you want to fail at some time, you can say that you must that you want to fail with the status code of 400 and with this message call to add block resulted in an error. And yes, 19, boom, eccolo qua. So fail creates an object by default with this structure with the error message call to add block resulted in an error, that it's the message that you have written here. A debug message that contains the call stack that caused the errors, but only if you are in a debug environment. In a production environment, this debug message will be equal to the error message for security reasons. And the error code 400 is replicated even here, as you can see, the 400 bad request. So if you want to return a 500, you can say status code 500 and it will be copied into error code and in the HTTP result code. Now, a second statement that it's here because in fact it is absolutely the very same thing is the assert. If you have a little experience with unit tests or some base C language or other languages that use assert as a native statement, you can assert that result code is equal to 0. Otherwise, if the assertion fails, return just fail with the status code 400 and this message. This code is in fact syntactic sugar for this very same statement. So it is the expression is copied and negated, and a fail statement with these parameters is created underneath. So this is very simple, easy, but if you have to handle more than one failure result code, you need other constructs. For example, this one is a different list. Fail with is absolutely equivalent to the one we've seen before. Fail with status code and the message. But here we add a when clause. So here we are saying if this expression, then fail with this status code. And here we replicate the very same statement, but with a different expression. It is important to remark that a fail abruptly interrupts the execution of the application. And sorry, not of the application. I hope of the request. So if this rises a fail, this will never be executed, and this object will never be created. The third kind of failure is the switch failure. That it's the most complete, and I think it's these and the assert are the most used inside our base scripts, but I may be wrong. So very same store procedure add block. Then here we have different status codes. Case 1 means missing container, while 2 means missing blocking reason, and a status code different from all of these is the else status code, and we always return a 400, but with different results. In the message, we can insert a constant string or an expression that it's evaluated during the exception construction. Pay attention to this. It's just like the try-catch. It's in fact a goto underneath. So this means that if we issue, for example, the add block without specifying ID container, we receive the error message missing blocking reason in call to add block. That is here. This means that the store procedure returned 2 as a result code. And I think that the 2 is here, set result code equal to 2, and yes, and this is it. Okay, so I think we are finished with my examples. I now look at the chat. No, then I will look at the chat first. A question, a raised hand. Go on.
I think I missed it. Maybe you said it, but does this manage also exceptions? For example, I don't know, arithmetic errors or I don't know, syntax error where this would, result in an exception in a C#. Here we're just doing, validation checks. I'm wondering how, yes.
Two different things. Let's start from the second one, syntax errors. Syntax errors are handled during the compilation phase, that it's done at startup. This is not interpreted, it is compiled, so there is an initial phase when you run the application or restart the IIS container, depending on how you run the Dynamic-BFF. Anyway, okay. As soon as you restart, the code is compiled, and until you solve all the syntax errors, the application won't start. So it's a fail-fast approach. Instead, if we have an unhandled exception, and you always have unhandled exception, you have no try-catch statements in this language, because unhandled exceptions are in fact handled by the subsystem, that returns you a JSON with this very same structure by default. By default means that in a few minutes, my colleague will explain you the handheld extension of the Dynamic-BFF, where the messages are a little different. There is no difference in syntax. Everything you have seen until now is perfectly and totally valid in the inside the handheld extension. There are only additional constructs for the handheld, but regarding the error handling, the inside the handled world, error handling is done by the subsystem, even with the exceptions and unhandled exceptions and failures and assertions. So you do not have to worry about error handling until you need specific error handling, like in this case where you want to customize the error messages. So unhandled exception will not cause horrible blank screens or stuff like that, because the subsystem handles everything that could go wrong during the execution phase.
Perfect, thank you.
You're welcome. Okay, let's start from the agenda. The agenda is, yeah, first of all, is missing. You are absolutely right. And I will briefly explain you how it works. We have, first of all, the general Dynamic-BFF syntax, that it's this one, and it's now over. Now my colleague will start with the handheld extension, and I will kindly ask him to explain the agenda for his part later on. Okay, and he's okay. He already wrote it in the chat. Okay, perfect. Having a knowledge of the Smile 80 architecture, nothing more than what I have already said until now, so I don't think so. Web programming languages, no, I don't think so. I think that the only knowledge needed is that of more or less any programming language, because these are very basic constructs and obviously database interactions. So SQL, store procedures, input and output parameters and stuff like that. Okay, DSL, it's domain specific language, and or an internet connection technology. Yes, both of them.
No, just to make sure, Mattia, so Dynamic-BFF, it's the name you guys invented, right? It's not something that's existing.
Yes, because computer scientists are bad at naming things, so I just added a dynamic in front of the BFF name that someone else invented way before I came here. So I just added a dynamic to say that it does the very same job, but in a dynamic fashion.
Okay. Thanks for the confirmation.
Don't worry about it. Best friends forever. Yeah, you got me. And it refers to the out parameter of the store procedure. Yes, absolutely. The return value of the store procedure. Yes, sorry for that. I missed it. Okay, correctly. a store procedure might return values as out parameters, and these can be found inside the output namespace, as we have seen in the example. But if the store procedure returns even rows, the rows returned by the store procedure can be found inside the result set object, and the single row eventually returned by a store procedure is inside the result lowercase result object. So what does it mean? It means that if a store procedure returns the result of a select, it can be handled exactly how if it was a normal query with the select. But additionally, you have the output object with the output variables. So yes, the return value of a store procedure can be obtained via the result set or result object. Okay. I think there are no other questions in the chat. I see no raised hands. I think I'm done. So, Roberto,
maybe we could have a break, 10 minutes if you want, or we can continue if you want. I don't know. How's the general feelings? Let me know.
I think it's a good idea.
Okay. So
yes, me too.
10-minute break. So we get here at 15:40 or 50, and we go on with the handheld part.
Perfect.
Okay.
Talk to you
Thank
later.
you, everyone. See you later. Thank you.
Thank you.
Okay, perfect. So let me introduce myself. I'm Roberto, and last year I worked with Mattia to bring this project to life. Switch my camera on so you can see my face for a brief moment, so you don't remember my face when you will complain about our project. But it's not the case, because Mattia can assure this just works. Right, Mattia? It's perfect. So no one will ever complain about our project. So we had to make the Handheld project and integrate Handheld project inside Smile 80 project, Smile 80 product. And we last year in March we started, and we analyzed the legacy Handheld application. We took some ideas from the legacy application, and we created this project side by side with Dynamic-BFF to create a new approach about creating Handheld application flows. And then the application, the legacy one, I think, if I remember correctly, had something like 50 flows, 50 tasks or operations that it could perform. We created firstly the main one, so actual application that comes with Smile 80 product from version 1.2.0. Come with 10 flows, the main one divided into some topics, of course. I share the presentation. Okay. Okay, I hope everyone can see Handheld app overview slide. If not, please give me a sign. What is Handheld App? Okay, Mattia explained the first half of the presentation was about Dynamic-BFF. Dynamic-BFF serves as backend for Handheld application. We could say that this is a dynamic JSON-driven application, or we could say that we created a toolbox because it has nothing hard-coded inside about the flows or the business logic. So we provide an engine that is able to perform simple or complex operation that we call flows. A flow is made of steps, and each step we could call it a page, an Android page. Can show or request data, display one or more UI controls, and of course interact with the user via events. The entire Android project is based on Net 7.0 MAUI framework, written in C# and XAML. The legacy one, I remember, was written with Xamarin Forms framework. The target, Android target, is of course
Roberto,
Android.
sorry.
Yes.
Roberto, we are viewing both the slide presentation. Even the next one, probably you are sharing the Neuron monitor. Let's try again.
Please. Let's go. Okay, I'll try to share directly PowerPoint.
Yeah.
Thanks, Christian. You say full screen presentation now?
Not full screen,
No.
but we are viewing the PowerPoint.
Okay,
There should be a drop-down button.
It's good now?
Yeah, now it's okay.
Yes.
Okay.
Yes.
Didn't get it. Good. Perfect. So we were saying target Android 13, API 33. Minimum Android is 8.1, API 27, because it's the oldest version that the Handheld device are system operating system. I list here some features of the project. We have embedded graphics assets and templates that we can reuse. They were provided by the newly formed UI UX team during last year. We have a JSON configuration, as I told, JSON-driven application. So we have a JSON configuration that is loaded at runtime, and this JSON configuration is created automatically by Dynamic-BFF based on the scripts, of course. And we load also labels and localizations at runtime. We take them from the front end. So from the web UI. We have, of course, authentication based it's the same as the legacy application. So based on identity server with access and refresh token. We have authorization. This is a little lighter, we can say. So we have role and permissions, but no claims required. So it's a little lighter than the standard behavior of the web UI, we could say. We also integrated the printing based on the same principle of the legacy application. So SDM print spool table. Of course, we have barcode scanning. We took all the configuration for the barcode scanning from the legacy application. So we have the same logic, data wedge profile for Zebra, Honeywell, and data logic and Handheld devices. Let's talk a bit about the setup. Later, I will explain the Handheld training package that I shared this morning in the chat you have available. It will help you to set up everything to exercise or for testing the scripts that Mattia showed. So generally speaking, we should configure an Android device. We can do this with Visual Studio Android Device Manager, or if we install Android Studio, we should install Smile80 security certificate inside the device, because our APK, so the application is assigned with root certificate of Smile, and then we can run Smile80 app. We will see later all the detailed steps to do this, and of course accept any required permission. Storage permissions are required to save log files, of course. I share here a brief example of a real Handheld device that, of course, you can create with Android Device Manager. So we are talking about a real small display, 4 inches, 480 and 800 of resolution. And as we said, the latest, if I remember correctly, the latest devices that we tested the application on as integrated Android 11 API 30. As we said, log files are stored into the dedicated folder under documents. You need read and write storage permissions that are asked on the first startup of the application. You can file on all the log files inside documents as shown in the pictures. This is an example of an error that we could get inside our application. Of course, we can find all the details about errors inside the files that are created with Serilog, with the same configuration as all the other Smile80 project. Let's talk about application lifecycle. So when we launch our application from the device menu, we go straight to the login page shown below. At this phase, the application loads from the front end all the labels and localizations. Of course, if this loads fails, we have embedded the labels inside the application, standard one in English. On the first startup, with the gear icon on the right, we should set up some mandatory settings, and then we can do the login. We will see these settings later. When we do the login, we load from the Dynamic-BFF the JSON configuration, and we get the menu. The menu is dynamic, so it's filtered by role and permissions of the logged user. Of course, we can always log out or exit from our application, or we are forced to the login page when the token expires. So, of course, access and refresh token should expire both to be forced to the login page. From the main menu, we have the hamburger icon on the top right corner. We can go to the settings page to set up the application, as I already said, and we can start all the flows that we find in the menu. And of course, a valid token is required to start the flow, while a valid token is not required to continue operating inside the flow. This is to ensure that once you start a complex or a long operation with application, you can always finish the operation and you are not forced to the login page while you are doing this operation. Talking about the settings, so we have 4 settings. It's very simple. The authentication server address is used to do all the login and logout stuff. The application server address is the IP address where Dynamic-BFF is running, of course. And talking about release, so on site we should, of course, base our IP on the load balancer. So, for example, we use the load balancer IP followed by the dynamic suffix. And as the image shows, we can use for our local machine when we do some testing with the Android device, we can use the local IP address that is the standard host machine address for the emulator, for Android emulator. Of course, we have languages. These are taken from the dictionaries loaded at startup, as we said already. And of course, we have a barcode scanner device. At the moment, supported device are Zebra, Honeywell, and Datalogic. The application tries to understand which device is running on, reading the manufacturer from the operating system. But we can always change these settings in this page. And of course, it changes the data wedge configuration to support correctly barcode reading. Talking about authentication, follows the same flow as Web UI, so it is based on identity server. Users can be created with standard roles, and we set up the address, the authentication address in the application. Of course, we use just 3 requests: login, refresh, and logout. And we created for the Handheld a custom client ID that is named smile80_Handheld. This is to separate client ID from the standard one that we use on the Web UI. So, for example, if, on site, we can customize access and refresh token duration as we want. We could say that access token validity is checked with every backend call. And of course, the refresh token is used to obtain a new access token when the first one expires. And when both expires, we are forced to the login page. As we said, we use access token to get user info and to get JSON configuration from this static address on the Dynamic-BFF server. Authorization does not follow the same logic as Web UI, or almost follows. It's based on custom role permission, and these roles do not need claims. So, for example, these are the default permissions loaded when we deploy Dynamic-BFF. We have 4 standard permissions based on the menu, and then the inventory, put away, shipment, and quality. And these permissions are valid for all the roles in the right column. We can use a specific statement, the allow, to customize the menu of the Handheld by user, of course. Talking about localizations are based on the same tables used by Web UI. So we are talking about 3 tables mainly: language culture, language translation key, and language translation. We added a custom namespace to the translation. It's handheld.ui. Of course, this is to separate all the labels used by Handheld from the labels used by Web UI. Prefix is not necessary when we are using localization key on Dynamic-BFF scripts. So, for example, we could write location.backbutton to get that first label in the image. And we can say that talking about life cycle, Handheld application loads all localization from the database every time we go to the login page. So we can go always to the login page to get new labels, and we don't need to restart all the application. Endpoint used for localization, as shown in bold, is fixed and is called automatically by Handheld and exposed automatically by Dynamic-BFF. Printing always also use standard SDM printing tables. So we're talking about 4 tables: printer type, printer, print object type, and print spool. And of course, we need some printer defined inside printer table, and we get to choose the printer in this page, in this custom pop-up we created. We can set the desired copies, and we can send the object to print inside to save a record inside the print spool table. Printing is based on 2 endpoints that are defined in a common script configuration file. We call it print and get printers. These endpoints can be customized to achieve custom behaviors. So we can customize the print action and also the printer list that we get on Handheld. Talking about scripting source path. So when we have our Dynamic-BFF ready, we should look inside app settings.json to find our script section with a directory section that is an array, is a list of folders that are used to merge all the scripts when Dynamic-BFF starts. We can, of course, put a single folder here or a list. Deployment pipeline copies release script folders to the root path where the services are installed. So at deploy, we find Dynamic-BFF folders beside all the other services, and we find in the same folder our script folder ready with all the release scripts that we included in the product, of course. Talking about folder organization, of course, we organized all the Dynamic-BFF scripts in different folders. They are grouped by domain, or we could say topic, because we want them to be easy to maintain. And Dynamic-BFF loads all the scripts recursively, of course. So we can say we can put all on the configuration just the root folder, for example. Talking about menu scripting, so the files that we use to define the main menu, we can split all the menus into different files. Dynamic-BFF automatically merges all the menu statements and shows them sequentially. So, for example, this was used to separate standard SDM scripts from picking service scripts. So if we have a deploy picking service installed, we also get all the flows from picking and the menu, of course, the menu from picking. Talking about syntax, as Mattia already said, the syntax is almost the same, but of course we have additional syntax statement and elements that we use only when we are working with our Handheld. So we could say that we have a syntax element to define a menu tree with submenu, of course, flow and permissions. We have a syntax element to define a flow that we already said is a complex operation that can be performed by Handheld app. We can, of course, define all the variables or parameters that are used by the flow with the data syntax element. The step syntax element helps us to define a step, what is a step inside the flow, and which controls we want to render in that step. Of course, we need statements to define controls with parameters and user events. And lastly, we need a syntax element to define actions. So we can define an action or a chain of action that must be executed when an event is triggered. So for example, when the user tap on a button on the UI. Let's analyze all these syntax elements. Menu, and that menu is defined as a tree, is composed by flow, and of course can have submenu. Each node can have permission restriction, and as we already said, menu JSON is updated each time we go to the menu page, so it's dynamic. If we add another flow or another submenu at runtime, we just need to go to the menu page to get it visible. This could be a structure of the menu with different permissions. Flow 1 only for supervisor, submenu 1 for everyone, but submenu 1.1 just for admin, for example. In the picture, you can see an example of the script. Very simple. So we have the menu, submenu for shipment, put away, inventory, quality. Inside the submenu, you can see the allow statement. So we require handheld inventory to permission to see this submenu. And of course, inside the inventory menu, we see two flows. On the right, we can see an example on the handheld application of the menu shown in the script. Talking about the flow, as we said, defines a simple or complex task that can be performed. It's composed of a sequence of pages that we call steps. We can declare variables or parameters that we can use inside the flow, and we store these variables inside three different dictionaries we call context, model, and collections. So context is kind of system defined, contains all the variables needed by the flow. For example, we could say the page title, flow title, or step title. Model is user defined. We must put into the model all the variables needed to perform the flow business logic. Collection is also user defined, and is useful to store big collection of data, such as lists or arrays. Lastly, we have steps, of course, steps necessary to perform the flow. All dictionaries above are always shared by all defined steps. On the right side, in the picture, we can see a simple flow declaration. So flow with an identifier, context section, as we said, model section, collection section, and steps section, of course. Flow data management. So we said that we have three different dictionaries to store flow data. Why is that? Let's analyze the scope. Context is available and visible only when we are in a step or when we are in a flow. Model is visible when we are, of course, in a step or a flow. Is visible when we are inside a UI event. So for example, during the tap event, so we tap on a button and we have the model available with all the declared variables. But also the model is shared with Dynamic-BFF. And this is a difference between model and collection, probably the main one. So collection dictionary is only available at UI event or at step flow scope. Lastly, we have a local dictionary. We didn't say it before. Local is just automated dictionary created by the application, by the engine, and is used to store some information about the UI event. Of course, local is also shared with Dynamic-BFF, so we could say this information on backend side. We could say that, so model dictionary must contain should contain all the business logic, all variables necessary for backend request, of course. Context dictionary is useful to set up some flow or step properties. For example, the page title, as we said. Collection dictionary should contain just heavy or less dynamic data, such as lists of array and array. Local dictionary is managed by the action engine and stores data related to the action. So, for example, we could ask the user a question, and we want to know if the user taps yes or no. We get this result inside the local dictionary. Of course, as the last sentence says, every time a backend request, so we call the Dynamic-BFF an endpoint, we call an endpoint. Every time this request modifies the model, because we send to the Dynamic-BFF some variables, the Dynamic-BFF modifies these variables. When the request returns, the corresponding dictionary, so the model, is updated, and this causes a refresh of all the UI controls, of course, that are bound to that dictionary, because of course maybe we are showing this information to the user. We keep, of course, as we said, we keep lists and arrays in a separated dictionary, the collection one, because doing so we avoid the user's refresh for heaviest UI controls, such as the collection views that, of course, can show the list. We will see this better later on with an example. Talking about the step, so a flow is defined by one or more steps. A step is a page containing one or more UI controls we decide. The first step is always the starting one. The last step does not necessarily have to be the final one, of course. So steps do not need to be sequential, because non-linear or branching navigation is allowed inside our application. So we could say that a step is made of a context, is the context dictionary, and this one has priority over the flow one. So, for example, if we define the step title inside the step, we are overwriting the flow title, the general flow title, or otherwise we could inherit the title from the flow. Then we have events. We use this section to catch and manage navigation and contextual events. For example, we want to do something on init. So when we navigate to this step on initialization, or we want to do something on restart. So we can restart an entire flow at some point, and we want to do something when this event is triggered. Then we have controls. Of course, we need to define all the controls we want to render for that step. For example, we can define a label, a button, a list, everything. On the right, you can see a simple step definition. As we said, we have an identifier, step one. We have the context section, events, and controls. Talking about step layout, of course, we tried to create a standard and static layout. We try to create a standard static layout because, as we said, all the controls, all the UI controls are dynamically defined in our script. So we do not know which are the controls so we are going to render. So we have a static or main page button. It's always visible. It has the eagle icon. We can use the eagle icon to go to main page or main menu. We have a restart flow button. Is an X icon, and this one is optional. Can be defined for the entire flow, or can be defined for a single step if we want. We have, of course, the header section with the title. as we said, we can print here the flow title or a more specific step title. And this section has fixed height. We have then bottom the footer section with context buttons. This section has a dynamic height, can show a maximum of five buttons per row, left to right, and it expands on multiple rows if it is necessary. This section is hidden, of course, if we do not define context buttons. Then we have the body. The body is divided into a top body section. This one has non-scrolling content, so we could say it is sticky top, always visible. Then we have sticky bottom, so bottom body section, no scrolling content. And then we have the body section with scrolling content. So everything that is not defined in other positions goes to the body section that, of course, can have a scroll bar visible on the right side and can have, of course, as many controls as we want. Then we have, of course, we added to allow for more customization of the UI layout. We added a front section that is rendered above all the other. So we have top front section, fixed position, and we can say that the label is above the list that is underneath. A bottom front section with fixed position and the center front section with fixed position, of course. So as I already said, if the position is not defined, UI controls are added automatically into body section that has a vertical stack layout, of course. Talking about controls, so this is the list that contains all the controls that we defined. Of course, this one are the one that we needed last year while we were preparing the 10 flows that I said. So we have a label to show plain text or probably a localized labels. In this case, text composition is possible with placeholders. So, for example, we can write a label with missing parts, and we can put in a placeholder that will be filled with some dynamic data taken from the flow dictionaries. Label can be customized with font size and font family because it has a style property. We prepared, of course, with the graphic assets, some styles that is possible to use. Then we can the entry. The syntax token is input to write down some input from the user, or keyboard can be configured for text or plain numbers. Then we have barcode. It's like the entry, but enables barcode scanning. So if we have a barcode control in a step and we scan a barcode with our device, the scanned text will be automatically pasted into the text box. Then we have the button, of course, it shows a button with a text and or an icon. And this one, of course, can trigger one or more actions when it's tapped by the user. We can define the button inside the context section of a step. In this case, this button is not shown in the body, but is shown in the footer section as a contextual button. Then we have the collection view or the UI controls defined in Microsoft Net MAUI framework to show list. So we called it list. You can show a list of data. Usually this data is stored into the collection dictionary, as we said. Item layout can be customized with a template that is integrated in the graphic asset of the application. List control has a another section that can show title, icon, total items, can display, of course, item with an expanded or collapsed style. Of course, we will see examples of this later. Can have a selection, single, multiple, or none, and can have a filter to allow for easy searching of element. Then we have the templated view. Templated view is dynamic control. We call it view. Can show complex data usually stored into model dictionary. And item layout, as for the list, can be customized with a template. Then we have the progress bar to show, of course, progress based on, for example, a number that we defined in the model dictionary. After the controls, we get a brief overview of the actions available in our Handheld application. We divided all the actions in group. So, for example, we have the navigation group, all the instructions or the statement that we can use to navigate inside the flow. Go menu, go to mains menu, go step if you want to go to a specific step in the flow. Go back, we navigate to the last visited step, of course, if it's possible, if it's not the first one. Go next to go, of course, to the next step in the sequence, if possible. We can restart the flow with the syntax token restart, meaning that we reset all the flow's data to its initial value, and we restart from the first step. Or we can use complete syntax token or complete action. Shows a prompt, a little pop-up to the user with a configurable message, a restart button, or a main menu button. And of course, we can stop our navigation. So we can stop the current action chain. We can stop always or conditionally based on some condition that we can define. So we are executing a complex event. We tap a button that should execute 10 actions. We want to stop in the middle because we can continue. We should use a stop syntax token. Then we have data actions. Reset or reset all is useful to reset specific or all data from a flow, and we get these variables back to its default value. We can, of course, send a request to Dynamic-BFF to execute a task, or for example, load a collection. We can use call or load. Or we can execute one or more Dynamic-BFF valid operations, all the syntax that Mattia explained before, with the action syntax token. So we, with this action, with this syntax token, we are creating a proxy controller automatically, and it's called automatically. And so these operations are executed at the backend side. Then we have notify pop-up actions to, of course, show a message to the user. We can use toast. We can use show or prompt to ask questions to the users. Can be configured with formatted message with placeholders, as we said, and also custom buttons. Pop-up action shows data in a dedicated pop-up window. It's shown above the step, and this can be closed by tapping outside or with a dedicated X icon. Layout of the pop-up can be configured with a template, of course. Then we have the print action, as we said, or as we saw before in the picture. It opens a window to select printer and put the side copies, and then sends this request to STM print spool table. We have a validation group, so we can validate data in our flow or in a specific step. We can validate data based on some validation that we can define. And of course, if the validation fails, we can stop the current action. The difference between validate and check is that check is silent. So when the validation fails, check does not alert the user. The user is not notified, but of course a stop is applied nonetheless. Then last, we have conditional expressions, if, check, and break. If, of course, enables our application to do some branching decisions. So we can verify a complex expression with if-else statement. This is executed at the can side, again with a proxy controller. And then we can jump to if or else block based on that result. And of course, we allow for multiple if-else nesting. We can, of course, exit from an if-else block with the break statement. If check is similar to if-else expression. The only difference is that we can verify only simple conditions, so simple data that are defined inside our dictionaries as we saw. So, for example, we have a variable inside our model dictionary that is a Boolean, for example, and we can check this variable to see if it's true or not. And this is done at client side, of course. We do not need a proxy controller or Dynamic-BFF to do this check. For the rest, of course, is similar to the if-else conditional expression. So multiple if-else nesting is allowed, and we can exit from if-else block with a break. A break when, of course, is used when we want to exit from the current if-else expression. Okay, so now we should talk more about the syntax, and I think we should go to our programming guide. But before this, I want to point out, I want to share my screen. Do you see my screen?
Yes.
We see the
Yes.
slides,
Okay.
the PowerPoint slides.
Okay, now let me read now the chat. Does the server address support also host names? I think so. I'm answering to George's question. I think that you can write everything, so also a host name in there, because the application just builds the URL and calls it. But we can try, of course.
Thank you, Roberto.
Okay, so before we take a look at
Roberto?
the programming guide. Yes.
There is a raised hand.
Before you move on with the programming guide, I have questions related to the printing part, especially
Yes.
the slide number on page number 20.
I go back to there. Okay.
So first thing I see is that the meaning of the fields are not actually matching the same meaning the labeling system has. So let's say printer type, as so far means stands for the driver you want to call for, you want to handle. It can be the ADUS printer, the Zebra, the Datamax, and so on. So it's not just manual or auto. You can have the Markham. You have many type of automatic printers and many type of manual printers. So for us in the labeling system so far, this field has a specific meaning and indicates which is the driver the labeling system software has to use to communicate with the device, first of all. Second thing, the printer, you are saying here manual or and active printers. But actually, if you have to send a manual label printing request, that is used for the manual printers, where you have a print spool and so on, because the active printers, as you call them, are managed by the PLC. So it's the PLC of the conveyor of the machine that sends the request to the labeling system and asks for the label to be printed. So for those printers, let's say the monitor, how we call it, it's not the database, so the print spool table, but it's the PLC request. So this is another meaning. And the print object type so far stands for the type of pallets you want to print. So let's say you can configure it as finished goods or shipping pallets or manual picking pallets and so on. So I think we need to discuss this apart in a different meeting, but these three fields have completely different meanings on what the labeling system is handling right now. So I don't know if these are just example, you were guessing the meanings or what?
Okay, thanks for the clarification. Surely we can say that we should do a separate meeting to discuss all of this. I think that we actually we do not have a very deep understanding of how the printing system works. We just last year asked about some information about it, and what we get is what you see in this slide. So if the meanings of these fields are all different, I think we can, of course, discuss about it and patch it up on the application if needed. But of course, we, as I said, print action or printer list action are two basic endpoints that can be customized. So when we deploy the product, you get two endpoints ready for you to use. And these two endpoints just do what this slide tells. So for the printers, you get only manual and active printers from the table. And from the print action just sends a record on the print spool table. But this can be customized, of course. So
but that's the point. It's not a customization. So if you call get printers and you get back the active printer, that's an error, because if the active printer is managed by the PLC request and you send a request on the print spool, first of all, we cannot process that record in the print spool table. And second thing, even if we do it, then no one is giving a feedback back to the PLC, because the communication is monodirectional. It's the PLC raising the request and the labeling system replying to it. So I'm saying there's a problem on the basis of the management and the meaning of the fields and how you think it's working is not like it is working right now. This is the problem, not the customization.
Of course.
Let's set up a separated meeting to discuss this item so that we will address
Yes, I agree with you, Tuan. If we want to, we should fix this, of course. We can fix this, and we will have a meeting with you and others people.
Okay.
You can tell us how actual it works now. So
okay,
we can fix. Okay.
Sure. And so about the customization, and when you say the print endpoint can be customized. That means like if the barcode read by the scanner has a different meaning, like it's a skew rather than a work order, we can customize this and telling the software that this barcode means it's representing this object rather than another object. Is this the customization you're talking about?
Actually, you have an endpoint written in the Dynamic-BFF script, so you can write down whatever you want and all the checks you want, of course.
Okay, perfect.
I will show you these endpoints later, so you can get a better understanding.
Okay, thank you.
Okay, I think we can go on. This morning I shared with you in this chat this zip file, Smile80 and their training setup, and our extension for Visual Studio Code. I would like to talk a bit about this now, make you understand what this package is about. So this package is this package just contains APK and certificate. So you have APK to install on the device, certificate to install on the device because before the APK. Dynamic-BFF standalone published executable, ready to run with all the scripts ready and available. This is just a SQL file that I used to set up my demo. We'll see it later. We have the screen of a sample Android device that I showed during the presentation. And of course, I prepared a README file with all the steps that you can take to set up an Android device and use it to test on or to exercise with the scripting language. So of course, these steps should be very easy. If you have some problems, of course, tell us. Basically, you need to install Android Studio application or use Android Device Manager from Visual Studio. This is what I'm talking about. Tools Android Device Manager, where you can set up an Android device, of course, whatever Android device you want. You need, of course, it's better to configure the Android device, as I said, similar to a real Handheld device to get real resolution. Then you should copy Smile80 certificate to Android memory or SD card, install it from the security menu. Then you can install Smile80 in the APK. You can drag drop use a dp command as explained before here in step 5. Then you can run Dynamic-BFF locally. To do so, just need to go to this folder and run Dynamic-BFF service.exe. It should be ready to work. You could check this, of course. Okay. Yes, if you see something like this, Dynamic-BFF is running, is listening on localhost at this port. As I've written here, you can easily check if Dynamic is running with the get localization endpoint written here. So simply put this request on a browser, and you should get all the localization and the dynamic BFF is running correctly. Okay, so where were we? Okay, dynamic BFF. Dynamic BFF is set up, loads all release script by default. We can find all the scripts here. Release, version 1, common, being SDM. We can check the configuration with offsettings.json here. We can see that Dynamic BFF is configured to run common and SDM scripts by default. That is the standard behavior, of course. You can, of course, change this directory to load other scripts if you want. For example, you can load all the develop scripts. Later, I will show you this docs. Or, for example, you can load all the scripts of this presentation, the one that Mattia shared in the chat, and the one that I will share it in the chat later. Training.zip from Mattia here. Then, of course, after we have Smile 80 running, we need to run our application. So, as we said, encryption and credential. I have already installed the certificate CA Smile 80 here. And of course, I've already installed Smile 80 APK. You can see it here. So if we launch the application, the first time it will ask for permissions, of course, storage permissions. We need to allow it. The second time, and then it will ask for settings. Ignore the auto login. Settings page, I've already configured it as written in the README. So we can say authentication server address, application server address, it's localhost, of course. Language and Zebra model. The default is Zebra, of course. You can see that is running because every time we go back to the main menu, it loads the menu. And do it again. Here we are. Okay, so we get the JSON configuration with all the menu that we defined. The login is a dedicated user on this virtual machine, hhadmin, with a standard password. With this configuration, you should be good to run Dynamic BFF with all the scripts and, of course, the application. Okay, now what I do? Okay, now we can change our script folder. This one will be loaded. So I changed the directory, and of course I just run again Dynamic BFF, and it loads all the files inside develop docs folder. Let's close this. So we have, as we said, the definition of menu for handheld application with all the flows or submenus. We have other files with, of course, all the flow defined in the generic API.source with all the endpoints defined. We also have a common file. These are available in all the folders, training or, of course, release. As we said, this contains localization endpoint. It's just a select statement from this view. And this one just loads up all the localizations for Handheld. I will show you now. As we said, all Handheld localizations have a fixed prefix, Handheld.ui. So, for example, here we can find everything that we are using at the moment for the localizations of the Handheld. For example, Handheld.ui.demo are some localizations I loaded for the demo that we will see later. Of course, this endpoint can be customized to be whatever we want. For printing, as we said before.
Sorry, Roberto, about the localization, I have a question.
Yes.
Is there a way to export the keys in a file, send it to the translation office and import it back somehow for another language?
Yes, I think if I'm not wrong, you can do export here. I don't know how to go back and just load it again. I think you just download all the JSON here, and then you can, of course, translate in any language.
Okay, perfect. Thank you.
And as we said before, printing. So we have get printers, endpoint, and UI print action. So these are the standard one that we thought should be correct. But if these endpoints are not correct, after the meeting, the dedicated meeting, of course, we will fix it and put it right. This one are also, of course, available to all Handheld flows. Okay, I think we can jump to our programming guide. And if this one is running well, of course, and we'll use some help from these scripts that we wrote during the development last year to help us showcase everything that the application can do, and also to beta test some functionalities. We'll see this piece by piece. Okay, so programming guide, the Dynamic-BFF sections. The first half of the programming guide is a detailed explanation of what Dynamic-BFF is. Practically everything that Mattia said. Of course, I'm not going over this again. So we have explanation for API, web API controllers, authentication, data sources, all the data types, expressions, built-in function, etc., etc. And finally, we have some real-world examples based on the flows that we wrote for the product, of course. We are going to get an overview of the Handheld mobile section, of course. The first sections, again, we already saw how to set up the device. We already saw settings, authentication and authorization. I'm not going to repeat myself. Localizations and printing. This one we already saw. Let's dive a little bit into script syntax sections, resources. So we said that the Handheld application has some resources, some graphic assets, and these are explained here. Fonts, font family, font size defined, all the color that we defined with the UI UX team, all the icons that you can use inside the script are defined here with their name. All the styles, for example, that you can use on a label are defined here, and so on. Let's jump to keywords and namespaces. Of course, all the language, all the parser use some keywords that are, of course, reserved. So we should not use all the keywords and namespaces when we are declaring all the identifier, for example. So if we go into menu, you want to give a name to our menu, we should call it somehow different from flow, menu, title, and all our other keywords, of course. As we said, namespaces are model, collection, local, request at backend side, output for our store procedures, and result for our query. In here, we can find also all the variables that we defined for our local dictionary. As I said, the local dictionary is automatically created by the application engine. And based on what we are doing, the local dictionary will contain one or more of these variables ready for us to check. For example, if we tap an item on a list, data context, it's the item that we just selected. And we can jump to template section, maybe the most complex one. I think that I will ask the help of our application for this example. So a little note about layout positioning. As we saw in the slide, this was the example, of course. You can see that we have sticky top that is not scrollable. We have all the body that's scrollable, and we have a sticky bottom behavior. So, of course, we can show with this button the front layer that it's over everything else. Of course, this one hide the body. So we're talking about templates, probably the most complicated features that we added. So templates are used to display information in a standard format. So we can show an example of a data template. We should say that data templates are for list and control templates are for view. So our view control or our list control. So for example, if you want to show a single string item like this, you can use string item template. Let's check our documentation. So used to show single value with an outer border. We can see that the source value is this. So let's see the example. We have a collection defined like this with 3 items, item A, B, and C. And if we declare a list using this template, the result is something like this. the most simple one. Okay, let's see. More complicated one, key value list template. So I'm going to open a real example. Okay, so this is a simple flow created to show a key value list. We declare our collection. We can name it key value list, and we have only one step. Step one, as we say, the title is key value list template on init. So we have these events on it. So when we open the step one, we want to execute this section. This section is the load. So we are calling this backend endpoint, and we are taking the result and putting it into key value list variable into collection. This variable is, of course, used as the source for our list control. That is the only one control in the step, as we can see here. There's a title that it is shown in the header. We have, as we said, an icon. The icon is info, and of course we have the total items free that is added automatically. So the list control takes this source from collection.keyValueList, and applies this template key value list to show it. And we can customize our template with some params. For example, we want to add a template image that is shown in the right side. So the next icon is this right pointing arrow. Let's see how this conversion is applied. Let's go to this code. So we have a particular web API, sorry, controller, HHUI, meaning handheld UI controller. This one can be declared and used only by handheld application. Is a specific endpoint that we use to send requests to backend. Application use it to send requests to backend in a specific format. For example, we said that we share the model with the backend. So we can set a local list, this endpoint, with this information, free object, and then we use UI map. UI map is a special instruction that used by templates. So we are mapping local.list objects into another object with some predefined values. This template use these informations to build the left side and the right side. I can scroll this. Okay, we can see that source.value is used to show these informations, and template image is shown in the right side. So let's check with Postman what this call actually does. How is that possible? Oh, okay, I'm on the wrong. Sorry, I'm on the wrong folder. Let's switch folder. is the one I want to show you. So we have a simple get controller called get item. We set this record with some data about the person, and we use UI map in a complex way to show you everything that UI map can do, of course. Okay, I just call this controller. Let's put this on side by side and run this. Okay, so we're telling that we want UI map local person. We want that the key is the ID. So we get a field called key with the ID field inside, of course, one. We use this field to identify the record, of course, because we do not know which is the key of this information. So we tell the key is ID, and we get this information here that we can use later to identify. For example, we can identify that the user tapped this item in a list because we have this key. Then we have the prefix and the values. So we can say that we want all the values for the UI. We want the full name, that is the sum of these strings, Mr. or Miss, plus the surname, plus the name. And we want the age field as is. So we get value, object, full name, age, and we get localized prefix added automatically by this prefix demo. So we get demo.fullname. This is the key that the application will search inside the label dictionary. Then we have the style object, and we ask this that we wanted the status text and the status color because we wanted to highlight the gender, so male or female, with a different color. And we got this style object. This object is automatically used by the application to show some UI visual customizations. Then we have the source. We didn't ask it for the source, but the source is always available. It's the entire object, original one, that we asked to map, of course. So we can have a UI side on this object available for us if you want. We can see, of course, with the example that I made before. Sorry. Okay. Back. Get back power box. Okay. So as we said, UI map. We have ID, name, age, checked because we didn't specify any values here, just the key. So we are getting the entire object for us visible, of course, and we get the key that identify the object. This is just one template. Of course, there are more. See everyone. Of course, we have key value list vertical, just show vertical information with 2 rows, and others. Of course, they are detailed in the programming doc. Or simple value list, for example, if you don't want the label on the left side. The control template, as we said, are used with our view control. So let's see this one. Is it simple? Value list. So we have a single variable called template. We get this data on init when we open the step. Not here. Yeah, so it's a simple object. It's just these informations. And oh, yeah, we can of course tell this is a view. This is bound to model.template. This uses key value list template. We can assign a template title, a template image, even a template action icon, for example, gear icon on the top right corner. And with this syntax on action, we can of course trigger this event. For example, this is the template action, as we can see with the toast instructions. So of course we can customize this template. There are others. For example, one that we used often is the threshold, used to show fixed information. If we do not have space in the UI, we can hide the information. This template uses just 5 rows fixed by default. Okay. So as we said, template parameters are all the parameters that we can write to customize a template, title, image, action icon, or action label. We have style parameters. As we said, we can customize our UI map statement, adding a background color, border color, status icon, or status text. You can see this here in action. Example, status text. You can show some text on the record that we want. Okay, I'll show you the source. Here we are, this one. Okay, so for example, I can write something like this. I can use the value as status text and the color as status color. So if I write something of value or color, I get it displayed on the right side. If I put it, for example, if I set it to null, I don't get a text on the item, of course, etc., etc. And of course, all others are as simple as that. For example, border color or background color. About collection view, I think that, of course, let's jump into our control section. Collection view is, of course, one of the most complex control that you can write. Has a lot of parameters. This is an example of our programming guide showing you how to write a list. So in bold, you can write, you have the keywords, then you have all the parameters linked to the definition. So for example, if we jump to identifier, we go to the global section and we get the definition of an identifier. So it's an open identifier that can be a reserved namespace like this. And of course, open identifier is a name, face charter must be a lecture, etc., etc. So navigating the the programming guide like this, you can write everything that is available in the scripting language. And of course, you can write a list followed by an identifier and all the parameters that are inside the square brackets are optional, of course. So the title is optional, the icon is optional, etc., etc. Source is mandatory, and you get a little explanation of what every parameter does. So you can set up selection mode. Of course, the data template is mandatory. You can set up collapsible or expandable behavior, explained here. You can set up a filter, explained here. And you can set up, of course, all the events related to this control. For example, if we want to tap an item, give you an example. Here. Okay. So we have this step, two lists. List one is no selection, no tap. As you can see, it's very simple, just a title, an icon, a source, and the template. The second one has the on tap trigger. So on tap, we can say toast tapped item with a placeholder, because we can write here a formatted string with local.dataContext.key. So we get here on the first one, no tap. On the second one, we get tap. And the key, of course, is the key item that we decided on the UI map instructions. Of course, data context, as I said, is the item that we just tapped and is automatically available into local dictionary with specific events, of course. As you can see, we can have, of course, selection, as we said, no tap, so no event, and selection with tap. So we can write down in the toast what we already tapped, and we can see it appear that is dynamically injected into the label. Of course, we can reset selection. We can load a different source. For example, this one changes all the name, David mod, Paul mod, and Mark mod, and we get it dynamically, of course. Then we can have multiple selection. This is an example. We can select everything we want. As I said, the model is shared with the backend, so we, of course, can send this information to the backend. For example, if I tap check selection, we send these selected items to the backends, and the backends create this label telling us you select two items, item 3 and item 1, of course. You can find, of course, detailed explanations of all these behaviors into the docs folder that I gave you with the zip package. For example, if you want to see what this button does, check selection, it's here. And as we said, we are calling action statement. It just creates a proxy controller, so it's calling the backend, the Dynamic-BFF here, to do this instruction that is available only at backend side. And we are setting this label, multi-cell display, using a combination of our multi-selection. So we just loop through our selection and take out a string, of course, and the count of the strings of the selected items, of course. Of course, collection view, as I said, is the most complex one. We can have expand collection view, meaning that we can show an expandable, collapsible behavior to save space primarily. Of course, the item, as you can see, even when is collapsed, has all the information inside. So I tap the second one and I get down here all the information about this item. They are not lost, of course. Then we can have, as we said, the filtered collection view. For example, you can filter on any field you want. So I want to field on an ID, or maybe I want to field on the name. This is just configurable, of course, in the scripts. You can, of course, send the filtered items and the filtered text to the backend. This one, for example, it's this one. So how do you add a filter? Just writing something like this. Filter type input, meaning that it's not a barcode. I want to filter on key and on name because I know that the object has a name property, of course. You can find, of course, everything about this inside the programming guide. So if you want to add the filter, just tap on the filter and we can see that we must write filter type, barcode, or input. The only difference, of course, is that it uses as the text box a barcode or a simple text box. We can avoid telling it how to filter. The default, of course, is the key field, or we can tell it to filter on single or multi identifier. So, for example, we can do something field 1 dot field 2 dot field 3, of course, if we have nested objects.
Sorry, Roberto.
Yes.
When you filter, you do a filtered call to the API, or it filter on all the collection of data?
No, it's not. It's on client side.
It's on.
It's on client side. It's done by the application.
Okay.
So the control has all the collection inside. So
okay,
it just applies a filter on when you write something here.
Okay.
And of course, if you delete the filters or you get the entire collection back. From collection view, I think we have done. We've seen data template, control template. Of course, we saw formatted message. Let's see what is a formatted message. Quoted or unquoted name and expression. Expression is just the parameters that we can write for the placeholders, of course. We can write everything. And for example, we can write something like hello 01 surname name, and this is automatically applied dynamically by the application. So if surname or name changes, we get to see the latest value on the UI. And of course, we can use a localized string like message greet. We can take it from the labels, and the labels, of course, must contain something like this to accept these two parameters. If you want details about this, of course, formatted message.source has all the samples that you can the possibilities that you can use to format the message for a control label, a button, the title, or pressing maybe a pop-up. We can take the title. As we see a pop-up title for model, this is taking this variable, this information from the model dynamically from here. So we can build strings with placeholders everywhere, more or less. Of course, we have a dedicated section to notifications, toast, messages, can customize alert, errors, you can customize title, icon, pretty everything. We can have a prompt with the prompt statement. So simple one, just a label, yes or no. And of course, we can check the answer. Simple alert, custom prompt. So we can customize everything. Let's see how it's done. Here we are, custom prompt. So we have icon palette, title with a placeholder, option 1 taken directly from our model, and option 2 cancel. Of course, we can check if check, as we said, is made at application side. So if I write something, if check local dot option 1, I'm checking if the users tap this option. Local dot option 2, of course, is this option here. And we can toast, of course, the result. We could have a multi-button prompt, of course. It's limited to 3 buttons because we have limited space, of course. So we can write something like this, option 1, 2, and 3, and we can check which one we tapped, of course, with nesting. So this one is option 1, and on the else block we have the second if. So we can check, of course, even option 3. Let's go back to menu. Of course, we have labels. This one is just plain simple, so there's no need to explain anything. It's just a label with a text and a different style that you can see in the programming guide under the resources, of course. Branching, of course. This one is to show you, of course, the if else expressions. For example, you can check what the user has tapped with an if, maybe checking an inside property of the selected item. For example, you could do something really more complex with this nested ifs example. That is, of course, really messy. You can say that is a sequence of prompt, of course. Start, so you can branch 1, 2, stop. This one is to show you how actually stop works. For example, stop when local adopt option 3. So if I tap stop, it just stops, of course. I want to continue with branch 1 start, then branch 1.1 or 1.2, of course. I want to break from branch 1.1, yes, okay, so we are here. We want to break, so we don't want to show this. So we broke from the if check, and we are here. Show branch 1 end, of course. Finish, yes, it's right here. This one is just a little overview of all the capabilities of the application. Of course, this one is just to show, it's very simple, just to show that you can inherit this title from the flow, or you can define, of course, a custom step title like this. So you can see step title like this, step title. You go to step 2, context do not contain step title. So we take flow title, of course. Here we are. Okay, I think we have done for this part of the demo. And maybe we could start the real one. Of course, if you have any questions, feel free to ask. Let's see if I explained everything here. Of course, programming guide.
Just a time checking. There are about 20 minutes before ending the meeting. So just consider what we should do in the last 20 minutes and what will be postponed to the next Monday.
Okay.
Thank you.
Okay, so I finished the overview of the programming guide. Of course, we saw resources, templates, keywords, and namespace. Global is just a list of all the common syntax statements that you can find inside the scripting language. Then we can have the explanation of what a menu is, what a flow is, with a permission, a title, and an icon, what a submenu is, of course, the allow statement. You have all, for each section, of course, you have all examples available here, just to copy. Then we can jump to the full section, of course, flow identifier, but as we said, context, model, and collection, that is optional, and the list of steps, the explanation about the dictionaries. Context, as we said, can have a title. You can have a restart button. Let's see if we have an example of this. It's just show or hide restart to show the X icon on the right, on the top right corner. We have some, we have provided some syntax shortcut for the most common buttons. For example, if you want to show back, let's go here. This one, go back, has a shortcut, show back. Otherwise, of course, you need to write something like this, the entire definition of a button. Also a text, an icon, on tap event, of course. We have reset, of course, you can have a reset hold to just reset everything that it's declared in the current step. We have a shortcut for the print button, show print with something to print. And we can put some actions after the print action, of course. Or we can add a generic context button, of course. That is made in any desired, that can be customized, of course. Then we have, of course, the model. Okay, so maybe here we need to give a little explanation about validations. I think so. Model is list of field. Let's go here. Okay, this is a plain simple list of field, but we can add to this list a default value, not a text, a number, or a Boolean value. Of course, this is the value that is used when, for example, we call the reset action. We can add a display name. display name is used, for example, when we call the validate action and the field is invalid, we get a message from the application and the display name is used. In this case, if we want to do validate a field, we must provide the display name. And then we have field validations. For example, we can say that this field is required, or this field is has a min length, max length, min value, max value. All these are applied when we call the validation. So, for example, let's jump to validation section. Here you have a list of all the action that can trigger validation, blocking or not. Blocking means that if validation fails, the entire action is stopped, of course, and notified to the user, of course, or not, if this is silent, like the check. So, for example, if we say that a variable is required, we call this a behavior validation. So, for example, it's a string. If the variable is a string, the string must be filled with some text. Null is a fail validation, of course. All others validation, if we do not require, for example, if we leave this field like this and call validate model.singleCell, this one, when we call it without specifying the validation, is a generic validation, what we call a generic validation. So null is not valid ever. A string valid when the string is not empty, of course. Everything else is tried to convert. We try to convert to the bool. If we have an array over a list, of course, this must not be empty. Otherwise, we get true, valid, of course. So we can write something like this: validate model.field1 collection with a custom message or data context from an event. We can validate a control. Of course, you can say validate this list. And of course, validation is triggered on the bound variables. So the source or the selected item, for example. We can validate progress bar. It's valid when progress reaches 100%. We can validate the entire step. This one is a little tricky. What does this mean? A step. A step is just validates all the bindings inside that step. So, for example, we have step 1 here. We have list 1 and list 2 with a binding to collection, non-cell list. This is the validation. So we just get the list of all the controls. We get the bindings, the variables that are needed by the controls, and these variables are the ones that we validate. We can, of course, do sign validation. We can, of course, do stop when model check 1. So if model.check 1 is true, we stop. Of course, we can stop after a prompt or if checked. We have even some binding validations like enable when, visible when, hidden when. So when this field is true or valid, meaning generic validation, the UI control is enabled. So, for example, if we say a text box enabled when model.something, if something is true, the text box is enabled and the user can write an input, otherwise not. Or, for example, we can play with visibility. Of course, we can hide something when a variable is true. We can make something visible when a variable is true. where were we? The same is applied to collection. Of course, collection is a list of fields. Fields as a default value, display name, and field validation. Of course, and collections do not have min value, max value, value validations, we can say, as also as only required validation. Then we have the section for steps, of course. Steps is a list of steps. We have some insight here. A description with standard layout, as we say, as we saw in the picture. The single step, context, events, and controls. All the events we can write on a step on it. For example, when we enter that step on menu is an event with which we can customize this button. So the standard behavior of the menu button is this: ask the user for a confirm with a yes or no. We can customize this behavior with the on menu event, and the same can be done with the restart button on the top right corner. Of course, on restart event, it's of course the same. Just we have an example here now. We have on init, of course. We can write on restart. We move whatever we want here. Of course, you need to add the restart button like this. When you tap the restart button, this action gets executed. We have a special event here. We call it timer. Timer event. We can set up a timer event with an interval when we enter a step. So, for example, on timer interval 5, we just trigger all these actions every 5 seconds until we step out from the step, of course. And of course, you have at disposal the most complex section here, controls, with the explanation of all the controls that you can write, and actions, of course, as we saw on the slides, divided by group. So, for example, let's see API. We can call at identifier, of course, must be a valid API alias. It's a sample one. This one is an alias. And this one is an alias. So, of course, you do not need to write the entire URL and endpoint. You can write this. Or the load action is used to, of course, load collections into the collection dictionary, of course. So, for example, you can do something like this or something like this. Of course, all the actions are explained in here in the best possible way. Of course, you can find something missing. You tell us, and we are happy to integrate the documentation, of course. Okay, I think this that I'm done with programming guide. We have 10 minutes left. I'll just give you an introduction of what we're going to do next week. Now that we had a little and very quick overview of all the syntax, we're going to do a demo session that consists of 6 exercises. We try to build a simple flow and that is able to manage CRUD operations on the simple SQL table. So we have this simple table here, demo.person with fake data, of course. And we are going to analyze together these 6 demo exercises, of course. and each exercise has a specific task, of course. So in the first one, first three are just to read. Then we have possibility to create a person. We have the possibility to delete a person. We have the possibility to update a person. Of course, we could see, for example, the first one is the simplest way. Of course, I need to switch my BFF. Can just okay. Okay, it's on. Let's load the demo menu. Okay, so what are we talking about? So the task is show the people in one simple list, of course. The simplest way is writing a flow like this, of course. Flow demo one collection, we call it people. On it, we just get all the people from that table with this API. Of course, it's a real simple one. Let's close all the others. Of course, Handheld UI get people one. We just execute this get people here. It's a simple select ordered by surname and name. We return the result set, and of course, we map all the people with a simple key ID. And we want to show it in a list. Very simple people list with this icon. Use this collection with this template. This is the result, of course. And of course, it's very easy, but also very raw, you could say. You can find better ways to show this information. We will see this in the other demos. Of course, the final task, we expect demo 6 be the complete one. We want something like this to show only the information that we want to that are more useful in the list. We want the possibility to filter the list, possibly. We want to clear. We want the possibility to get notified of missing informations. Of course, we want to get into details for that person. Maybe delete that person, maybe print a label or something with that person. We want to the possibility to add the person with some fields, of course, maybe validated fields. And of course, we want the possibility to edit, maybe just the optional information. So this one is mandatory. You cannot change. You can change your phone number, for example. So I delete one, I hit save, confirm, and it completed. And we got the one deleted, of course. Check on database. It's this phone number here. Maybe not. 7. Okay. Michael Brown. Yeah, that's correct. And this is just a little overview of the demo. Of course, next Monday, I would like to analyze in detail this demo with you to show you how to achieve this simple task one by one. And of course, one by one, we introduce all others, controls, actions, and events as we need them. I think that's it for today. That's a lot, I know. So, of course, if we have questions, we have 5 minutes left, and feel free to ask. Fine. otherwise, I think we are done for this demo.
I have a question.
Okay, where can we can find the guide? Okay, on the zip package, of course, here, README, you can find the link on top for a programming guide. This one is the develop guide. This one is production guide. So it's the same, of course. This one is good. It's the same I'm showing you. So the question?
Yes. So for those who are familiar with XAML,
Yes.
are we not supposed to change that, or do we have to use this system?
No, this system is just made to avoid writing code, C# or XAML, of course. The idea is that you can use all the templates that we provide to show information, and of course, if you need more templates, of course we need to integrate more templates into the product.
Okay.
This, of course, is done to avoid that on a project, for example, all the application will be different. If we have a standard layout, standard graphic assets, and standard templates, of course, all the applications everywhere will look the same, of course, and will be standard for our customers. And we would like to avoid writing manually all the templates, because that create a lot of differences in styles and all others. Of course, we have the templates written in XAML inside the application, but as I said, when there is the need to a new template, we can write it in here, and it will be available as a product, of course, for everyone to use.
So Roberto, the customizations you were talking about the endpoints, is that part of the configuration process, as you call that?
Customization of endpoints, about what? Sorry.
I mean, you just said that with this standard product, we don't need to, we avoid to have different source code, as you said, and
yes,
everything is just
styles,
the matter. Yeah, it's just a matter of configuration. But then earlier you said that we can customize the endpoints. So this customization, it's something that you still call configuration, or?
Yes, for of course. When the APK, of course, and the Dynamic-BFF comes with a series of flows defined. Maybe, of course, we will see these flows next Monday, because they are the real product is here. Of course, what we saw today is just demos and examples, of course. So the application comes with this flows, and of course you can see in here that we wrote this. For example, this is handling unit details, so just let you scan an handling unit to get all the information about the handling unit. For example, it's a very simple flow, and we wrote it, of course, but you can change whatever you like in here, and of course you can change whatever you like in here when there's the query, there's the select, and everything else, of course. So here lies the customization in about business logic, of course.
Okay. So
otherwise,
we still need to
visually customization, of course, relies on templates, and of course they are limited to the one that we created and that we wrote inside the APK, of course.
Okay.
Okay, any more questions? Yes, no. So, Mattia, do you have something to add after all this?
I think it's enough for just one day.
Yes, maybe it's too much. Probably. Okay, so I think that we are over. Thanks for your attention, everyone. And I will share, of course, here on the chat all the examples that I showed today to you. And we can see you next Monday when we can do more detailed explanation of all the demo examples, as I already said. And we will have, of course, a real demonstration and explanation of the actual flows available in our application, maybe with help of the web UI to see it working real time. And of course, next Monday we will also answer to all your questions. If you can this week, try to set up the zip package I gave you in the chat, and try to see if everything works fine. If you can understand or try to understand, of course, the example and the syntax. And next Monday,